So today I thought we would cover a quick Ansible setup in GNS3. We just created the project, and now we are going to create two iOS VL2 nodes. That's the first one. That's the second one. Going to name the first one MLS1. And the second one, MLS2. And now we're going to start those nodes. Okay, the nodes are started. We're going to enter enable mode, conf t, and now we are going to assign an IP to the VLAN 1 interface VLAN 1, and then IP address 172.16.99.11 with a 24-bit subnet mask. Checking to see if that interface is up. It is not. We are going to no shut the interface, and now we are going to assign a username admin, password admin. Now it's time for the domain name, IP domain name. We're going to assign it test.com, and now for the host name, MLS1. Going to generate the RSA key, crypto key generate RSA. Going to go for a 1024-bit key. Now we are going to assign the username and the password to the VTY lines, and we are going to use transport input SSH because we are not going to be using telnet. And now on to MLS2. Enable, conf t, going to assign the username of admin and the password of admin, and now for the domain name, test.com again, host name of MLS2, and generate the RSA key. I'm going to use a 1024-bit key again. And now for line VTY015, login local, and transport input SSH again. Assigning the IP to the VLAN 1 interface VLAN 1, IP address of 172.16.99.12 with a 24-bit subnet mask. The interface is not up, so we're going to no shut the interface. Now it's up. Checking to see if we have connectivity. And we're going to create a connection between the two devices. Checking to see if we have connectivity between them. And we do not. Checking to see if the interface is up. It is. Going back to MLS1, going to try to ping MLS2 again. And we have success. Going to MLS2, we're going to ping MLS1. And we have success. Going to drop a cloud node into GNS3. Going to create a connection between MLS2 and BR-GNS3 on the cloud node. Going to configure it. Ethernet interface is BR-GNS3. Tap interface is tap GNS3. And now we're going to check to see if we have connectivity to the two GNS3 nodes. And we have connectivity between the command prompt and MLS1, and now we're checking MLS2, and we have connectivity. Okay, so I thought I would provide a brief walkthrough of the Ansible playbook I'm going to be using. It's called baseline.yml. I'm in Ubuntu. This is my local GNS3 lab, and I'm targeting Cisco iOS devices. The whole point of this playbook is simple. I want a baseline config that I can push onto routers or switches in the lab, and then immediately prove it actually did what I think it did. I'm going to scroll from top to bottom, and while I'm doing that, I'll call out what each part is doing, and more importantly, why I'm doing it that way. Okay, at the top, the play name is baseline iOS config and validation. This is not so much a baseline config, it is a baseline plus validation. Pushing a config without checking anything is how you end up having to troubleshoot something later. Now I'm moving on to the hosts line. I'm highlighting that right now. It says host :iOS. This means this play targets the group called iOS in my inventory. And yes, I am running this with an inventory file named inventory-ios.ini. If your inventory group name is different, like routers or cores or something like that, you change it here or you change it in the inventory. This is one of the spots where people get mad at Ansible when it's actually just the group name not matching. On to the next line, we're looking at gather facts :false. I'm going to highlight that. Gathering facts is great for Linux boxes. For network devices, you usually do not need it, and sometimes it just slows things down or fails in a way that's annoying. I'm not collecting a bunch of system facts here. I'm running specific show commands and pushing a specific config. So I turn off facts. Now I'm scrolling down into vars. You can see I've got domain_name set to test.com and NTP server set to 172.16.99.1. NTP server is not going to matter so much in this context. We don't have NTP set up on any of our GNS3 nodes. These are variables I want to tweak once and then use on multiple lines without copying and pasting. Also, this is one of those areas where environment matters. Domain_name is harmless. NTP can be harmless in a lab, but in a real environment, pointing at the wrong NTP server can cause logging and cert validation problems. And so if you copy this into something that isn't your lab, do not just blindly keep my NTP address, because you will have a bad time and your logs will not be looking very clean. Okay, so now I'm scrolling down into tasks. This is where the work is actually done. The first task is pre-checks snapshot key state. I am highlighting this because I want you to notice the order. I don't push the config first, I take a snapshot first. This uses cisco.ios.ios_command, and it runs a few show commands. The first one is show version with some includes. I'm grabbing uptime, system image, and model number. This is basically a quick fingerprint, and I want to know what I'm working on, and I want to know it before I actually start changing things. The second one is show IP interface brief. If the device is already in a weird state, I want to see it. Also, if I break something later, I want to be able to compare the before and afters. The third one is show run, again with an include filter. We are including hostname, IP domain name, username, and IP SSH. This is the part that's most directly tied to the baseline changes I'm about to make. After that, I am registering the output in a variable named pre. Register is important. Without that, you run commands, but you don't keep the output. It's like running a show command and then immediately forgetting what it said. Next after that, we have print pre-checks. I'm highlighting this line. Ansible.builtin.debug, var:pre.standardout_lines. This prints the output in a readable way. Standard out lines is basically the output split into lines, which keeps it from turning into one giant blob that you're going to have difficulty reading. This is also how you make your playbook self-explaining when you come back later. You run it, it prints the state before, and you don't have to guess what happened. Now we are moving on to the main event. Push baseline config. This uses cisco.ios.ios_config and is pushing a set of lines. I'm going to go line by line because this is where people either build good habits or they build something that is not going to work. The first line is hostname, double curly braces, inventory underscore hostname, double curly braces. Instead of hard-coding a hostname, this sets the hostname to whatever the device is named in the inventory. I don't want to maintain hostnames in two places. The inventory is already the source of truth for which device is which, so I reuse the inventory. The next line, IP domain name, double curly braces, domain underscore name, double curly braces. We have the same idea, one variable, one place. This makes things easy to change. After that, I've got service timestamps, debug, datetime, imsec. This is one of those quality of life settings. If you're troubleshooting and your logs don't have accurate timestamps, you are basically going to have trouble troubleshooting. Milliseconds are maybe a little bit extra in a lab, but I like it. Now we are moving on to IP SSH version 2. You want SSH version 2. V1 is outdated, and if you are in a lab, it will still work, but it's not something you want to normalize. Moving on, we are moving on to IP SSH time-out 60 and IP SSH authentication-retries 2. This is essentially a small security baseline. Somebody is brute forcing logins. Retries of 2 means they do not get a million guesses. The timeout of 60 in this context is especially generous, You can tighten that if you want in your own setup, but don't set it to something tiny and then wonder why your SSH session drops when you pause to think. Now we are moving on to login block -4 60 attempts within 60. This is another brute force slowdown. 3 attempts within a minute and you will get blocked for 1 minute. The next 2 lines, we have no IP HTTP server and no IP HTTP secure server. This shuts off the built-in web server features. If you're not using them, turn them off. You have less surface area for attacks, which, since we are in a lab environment, this is not particularly essential, but it is nice to have. Moving on, we have logging buffered 64,000. This sets a decent sized logging buffer. 64,000 is not a magic number. It is just enough to make logs useful without being microscopic. If you're on older gear or you have low memory stuff, be aware of that. Since we are in a lab environment, this is usually fine. Then we are moving on. NTP server, double curly braces, NTP underscore server, double curly braces. Make sure the NTP server is real in your environment. In this case, it is not real, but it is not going to affect things. Now we look at the end of this task. Save underscore win colon modified. This means that Ansible will save the running config to the startup config only if it actually changed something. That keeps your devices from constantly doing writes for no reason, and it keeps your runs cleaner. Also, it's very nice that you have a playbook that if you run it twice, the second run should be boring. Boring is the goal in this case. So now we are moving on to the post checks. Post checks, we are proving the changes took, as the name states. This again uses the cisco.ios.ios underscore command, and it runs show run with an include filter. I'm highlighting the pattern in this case. The caret before the host name anchors it to the start of the line, so you are not accidentally matching something else that contains the word hostname somewhere. This is a small thing, but it is one of the habits that keeps your validation clean. And again, I register that output, this time into a variable named post. Then the last task prints it. Ansible.builtin.debug var post.stdout underscore lines. So when the playbook runs, you get pre-state printed, then it pushes config, then you get the post state printed. That's the whole workflow. And that's why this is simple. If you're learning automation, you need feedback loops. You cannot just fire configs into devices and hope. In GNS3, it's especially easy to think you changed something when you didn't, because you targeted the wrong group, or your connection settings are wrong, or the module didn't run. Validation removes the guesswork. This playbook assumes your inventory and connection variables for network underscore CLI are correct, and that you've got the Cisco.ios collection installed. If you run it and it errors, like module not found or cannot connect, this is not YAML being wrong. This is your Ansible environment needing the right collection and the right transport settings. I am also calling this baseline.yml, but the play name says iOS config plus validation. Please note this is not a workstation setup playbook. It's a network device baseline. So if your actual goal is workstation setup on Ubuntu, this is the wrong file for that. this one is for iOS devices in the iOS group. If you want, you can still keep the baseline.yml file. Just know what it actually does so you do not confuse yourself in the future. Okay, so that's it. Simple playbook, clean loop, pre-check, push, and post-check. So I just wanted to go over the output of the Ansible playbook command. As we discussed earlier, we have some pre-checks that are performed in this section, and these pre-checks were performed. We have a uptime of 3 hours 5 minutes, excuse me, and a system image file that is outputted on the terminal, as well as the output of IP interface brief, the host name of the system, and the username, password, and domain name. This is outputted for both R1 and R2. Now, if you've been paying attention, the host name of the two devices is MLS1 and MLS2. Ansible believes the host name to be R1 and R2. This will matter later when we are done with the pre-checks and we've pushed the baseline config, which we've done right here. So we've pushed the baseline config as shown right here to R2, and we've pushed the baseline config as shown here to R1. Now, in the post checks, notice that R1 now has a host name of, MLS1 now has a host name of R1, and MLS2 now has a host name of R2. And if we look in the post checks, we see that the command has been executed, and the host name of MLS1 should now be R1, and the host name of MLS2 should now be R2. We can go over to MLS1 and confirm that with show run, and as we see, the host name is now R1 on what was formerly MLS1, and confirm this on R2, and the host name is now R2, as evidenced right there.